The thermoacoustic Stirling engine shall be made entirely from 3D printed components. For this, I've redesigned and printed the feedback loop over the past few weeks. It's not quite finished yet, but I couldn't resist doing a few test runs. The entire engine is finally sufficiently airtight, even though some connections are still provisional. Nearly 3.5 bar. It looks really airtight. The first test with the smallest inertance was disappointing. Probably the flow resistance is much too high. Now the burner is out, but the engine starts by itself, but with very low power. The next one, with a larger diameter, performed much better, which gives reason to hope for more. With a bigger hose, the power is much higher, but still not as high as with the original parts. I immediately drew and printed fittings for an even larger diameter. A quick test run revealed a significant leak. I will need to seal the fairly thin-walled PETG parts first. However, it produced the most powerful acoustic wave I've ever heard, which I recorded with a microphone. The frequency analysis in Audacity shows a strong peak at 350 Hz. I don't know if this is the actual acoustic frequency in the engine and if my method is correct. Maybe you are familiar with frequency analysis and can help? Please write it in the comments. The piston or diaphragm normally vibrates at a frequency of about 40 Hz. I'm going now to test the sealed inertance with a larger diameter and also experiment with much longer hoses. This brings me a step closer to my goal of creating a simple, reliable, open source acoustic Stirling engine that anyone can build and that can generate electricity from any heat source. You can download all the instructions and 3D models for printing at ownenergy.org. Any help is very welcome. It would be great if you could join the development of the thermoacoustic engine. As always, I'm really looking forward to your feedback, suggestions and opinions in the comments, on Discord or at ownenergy.org. Your help is incredibly important for the further development of the engine. If you would like to support the project even more, becoming a member on Patreon or YouTube would be a big help. Every cent from this will be invested in the development of the open source thermoacoustic Stirling engine. Thank you very much for your interest.